Math fans, today is a quick one, lesson 23.1. I'm on page 297, but there's probably a note page you could fill out, hint, hint, wink, wink, nod, nod, of what we're going over. We're basically going to talk about the official learning target is using artificial processes to simulate outcomes. Basically, we know that means analyzing pictures of chance. We're just going to kind of look at the pictures of chance, and that'll make more sense. It's basically the spinners and things we've been working with the whole time. I'm going to go over the first example that says, as an example, a spinner below was used to substitute for selecting a random bag of 40 candies in which 30 were milk chocolate and 10 were dark chocolate. Well, since I know my fraction, okay, I've got 10 over 40, right? And I also have 30 over 40. I could draw this picture to simulate that. This would be the 10 over 40, or we know how to reduce fractions, 1/4. Or you could say 25%, and this is the 30 over 40. Or we could say 3/4, or 75%. Right, so this picture basically just represents what we were told. Now, it's not only going to be always going to be that easy. Sometimes you're going to see a crazy spinner like this. Is this an exact picture? No, it is not. But I can estimate about how much this is. There's a lot of like wiggles and stuff in here. I can say, well, this part looks like it's about half. Is it a little less than half? Probably. Is it close to half? Yes. And I could say, well, this is kind of like a quarter and this is a quarter, right? Don't make it too hard on yourself by trying to calculate crazy fractions. Pick the one that it's close to. So is that exact? No, it's not exact. Of course it's not exact. But I got a half, a fourth, and a fourth. And if I add all these up, a quarter plus 50 cents is $1. Or a half plus a fourth is 1. They must equal 1. Remember, 1 is the whole thing. You got to account for the whole part. I know you got that. You'll see this crazy spinner a lot, like on the quiz. All right, you got a little vocabulary page. I'm just going to kind of clear it up. Some of these you know. Some of these you probably haven't gone over in a few weeks. A simulation. The book says artificial process for generating blah, 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 blah. Here's a good definition for it. Guessing what you should get in an experiment. So like when we were playing our card game or our dice game and I would roll 2, we should have gotten 7s, 6s, 5s and 8s all the time, but we didn't, did we? In fact, in one class we got 2 1s twice. Highly improbable, but that's what a simulation is. I'm just doing the experiment. An event in math is a collection which outcomes the probability, collecting the results. Okay, we're basically just doing the experiment. Like we guessed what we were going to get with our dice, but then I actually rolled the dice 12 times and we recorded that score. So let's say I'm talking about rolling a dice. My probability of getting a 3 is 1 out of 6, right? There's only one side. So I could write the probability of getting a 3 is 1/6. Well, if the probability of getting a 3 is 1/6, the complement of that is the opposite, the rest of it, all the rest of the possibilities. So if the probability of getting a 3 is 1/6, the complement of that is 5/6. And again, they have to equal 1 whole. It says for probability experiment equal outcomes event P written E. I'll sum that up for you too. Remember, probability is written like P with 2 parentheses and whatever you're looking to get in here. So the probability of getting a 3, 1/6, because one side of this dice is a 3. I know that makes sense to you. You've heard us talk about the words theoretical probability, and remember that's what you should get if you did it 1,000,000 times. Welcome back, Austin Powers. Oh, that's Dr. Evil, I guess. I got my characters wrong. What you should get if you did it 1,000,000 times. Like when we laid out our dice, it should have turned out differently, right? If we did it 1,000,000 times, we would have gotten that. But when you only do it 12 times, your sample size, Okay, it's a little bit smaller, so it doesn't always go the way you want. That's why it's called probability, because you will probably get that, but it doesn't mean you will. And then estimated probability is what you're actually getting. Like if you did it 20 times, let's think about our dice game we played. You all picked what you thought it was going to be, but did we actually get that? No, we did not actually get that. We should have gotten mostly like 6s, 7s, and 8s. But sometimes we rolled a 12. Sometimes we rolled a 2. Let's go. Last page. Look at these spinners. So we're talking about pictures and interpreting. You got to kind of look at them. Don't just like quickly guess on one. Which one is a good picture of a representation of flipping a coin? Well, what are my chances on flipping a coin? I could either get heads or I could get tails. Right? So there's only 2 options there. I know. Someone out there saying, well, what if it lands on its end? It's not going to land on its end. You could probably sit here all day flipping a coin and never get it to land on its end. I bet the chances of the coin landing on its end are 1 in 8 trillion. Somebody Google it. Anyway, look at these spinners. Is that a 50-50 chance? No. Is this a 50-50 chance? No, there's like 4 chances with this one, right? Is this a 50-50 chance? No. There's no third choice. This is the only one that's a good representation of all the outcomes. It either has to be heads or tails. It can't be anything else. And last but not least, a sample versus a population. You will hear that all the time. Well, think about it. The population will be everyone, like the population of the United States. And a sample is the part. Population, our whole school. Part, like a sample, my class or Miss Davies' class. A sample is a part of the population. And the better your sample, the better results you will get. There is a quiz today. Have a great day.